Salutations, mini mathematicians! Hope you're doing super, super well. I had just filmed this whole video and my computer died even though it was plugged in. And it didn't save anything. So that's fine. Stay lovey. Gotta roll with it, right? It's just gonna be better this time. So 3.2b, please write down your lesson purpose. Here you go. More simplifying expressions. We've been doing this with models, without models, sorting like terms, with groups, and we're just going to investigate distributing negatives today. So we're going to be using the distributive property, and we're going to connect expressions to word problems. So let's get started. You have your lesson in front of you. Be ready to pause the video whenever you need so you can be successful. So let's get started. We're going to review a little bit, just connecting to some word problems. What is the opposite of? So if you saw something we said we're going the opposite of 3 steps forward, that's right, you'd go backwards 3 steps. If you were gaining 5 pounds, the opposite of gaining 5 pounds would be losing 5 pounds, and the opposite of depositing $10 is withdrawing $10. Perfect. And the reason why we're talking about that is because when we are distributing negatives, we're going to be thinking about the opposite of something. So if we're thinking about logic from above, what does the following mean? If we have negative x, that's the opposite of x, or taking away one group of positive x. If we have a negative in front with x in parentheses, that's the same thing. We're taking away one group of x, or it's the opposite of x, whatever x is inside. So if x originally is negative, now it's positive. If x was originally positive, now it's negative. If x was originally 0, is there a negative 0? Nope, it's still just 0. Then if this is the cool part, and we looked at this when we were looking at groups, if we're taking away a whole group of x plus 1, we're taking away one whole group of x plus 1, or the opposite of x plus 1, so we would need 0 pairs. We only take away the positives, we're left with the negatives. Similarly, if we're taking away a group of positive 1 and a negative x, we're taking away one group of 1 and a negative x, or the opposite of 1 and negative x, so we're taking away a positive 1 and a negative x, we would be left with a positive x and a negative 1. So just a little review for you from before. So let's talk about what a few things represent. What does the negative in front of the set of parentheses tell us to do? Well, if you're modeling, it tells us to take away one group of whatever is inside that set of parentheses. Or you can think about, you were thinking about the opposite of whatever is inside those set of parentheses, just like we looked at above. So if we wanted to think about 3 groups of x plus 1, what does that mean? And then simplify the expression. Well, it means 3 groups of x plus 1, like I just said. So here, 3 groups of x plus 1. Whenever we distribute, we're always going to lasso up or circle the number we're distributing, and you can draw lines or arrows to every single term inside the parentheses. You can put as many terms as you want inside those parentheses. So this gets you 3 times x plus 3 times 1, 3 groups of x plus 3 groups of 1, which gets you 3x plus 3. Nice. The next one that we're going to be looking at is, but what does this mean? When you have a negative 3 times the quantity of x plus 1, and then simplify the expression. Well, this means take the opposite of 3 groups of x plus 1, or take away 3 groups of x plus 1. And let's show what that means. And again, don't forget to be writing down on your paper everything that's on my paper, and I understand you might need to pause the video to do that. So we're going to lasso it up and distribute it to everything in those parentheses. Almost look more like I'm fishing than lassoing, casting it out. So here we have negative 3 groups of x plus negative 3 groups of 1. I'm always going to write adding in between the products here. I'm always going to write adding, and I'm just going to worry about the sign when I look at the products. So negative 3x plus negative 3, which gets us negative 3x minus 3. Beautiful! Let's keep going. So next problems, what we're going to be looking at is simplifying each of the following and be ready to justify your answer. I'm going to have do with you 6, 9, and 12, this column, and you're going to do the other problems on your own, and we'll check in together. Remember, columns go up and down, rows go side to side. So this, we're going to lasso up the number being distributed, 14 groups of x plus 14 groups of 1, 14x plus 14. Beautiful. Let's look at the next one. Lasso up the number that's being distributed, negative 2.4 times x plus negative 2.4 times 3. And again, I'm always leaving it as addition in between, so I don't make mistakes with my signs. I just look at the numbers to figure out the signs at the end. Negative 2.4x plus negative 2.4 times 3 gets you negative 7.2. So my final answer, negative 2.4x minus 7.2. Remember, your variable term goes first, the term with the variable and the coefficient. Your constant term, which is a number with no variable, goes at the end. And the last one I'm going to be doing with you is a fraction, so I'm going to be lassoing up that negative. So negative 2/5 times 5 over 1 plus negative 2/5 times negative 3x over 1. Always look to see if you can cross cancel to make this easier. So then we're going to have negative 2 plus a negative times a negative is a positive. That's going to be me 6/5 and x. This x does not belong in the denominator. It belongs as the variable that's being multiplied by all of 6/5. If you put x in the denominator, then your entire expression changes because x cannot be 0 because then you'd be dividing by 0. We do want that variable term in front, so 6/5 x, or you can put the x in the numerator with the 6, minus 2. Notice my 2, my constant term, was negative. It's still negative. My 6/5 x was positive. Hey, it's still positive. So you're going to finish 7 through 14, show your work, do your best work, and we will go over those as soon as you're ready. So go ahead and pause the video, and we will go over those problems as soon as you are ready. Okay, let's see how you did. First one you had to do, notice you're distributing a negative 1. If there's not a number there, but there's a negative, it is a sneaky, silent, shh, negative 1. So again, I wrote negative 1 times x plus negative 1 times 2.7, which gets me negative x minus 2.7. Next one, again, it is that sneaky, silent negative 1 that's being distributed, negative 1 times 37x plus negative 1 times 2.8. I always put plus in between the two products and worry about the sign after I look at the numbers. I get negative 37x minus 2.8. Let's look at the next two. Here we're distributing a negative fraction. I have negative 3/7 times 1/6x plus negative 3/7 times negative 2/9. Again, always leaving this as addition. I could have cross-canceled here with the 3 and the 6 to make my simplifying a little easier. Again, with the 3 and the 9, I could have cross-canceled. I did not, and I just did it at the end, but I probably should have cross-canceled. Negative 1/14 times x plus 2 over 21. And then over here, number 11, distributing that 2.1. Make sure you're lassoing up and distributing. Negative 2.1x plus 9.03. And the last two that you had to do, distributing that negative 1, that sneaky silent negative. Negative 1 times negative 4 plus, always writing it as plus in between, negative 1 times negative 3x, so I don't lose my signs here. Negative times a negative is a positive, negative times a negative is a positive. I always want to put your variable term first, your constant term at the end. It's like spelling it correctly. And then your last one you had to do, oh no, you can't multiply mixed numbers, so I turned it into an improper fraction. Woe is me, right? I had to turn it into an improper fraction. Multiplying across, I have negative 13/4 times 2x over 1. Notice I did remember to cross cancel this time, yay! Plus negative 13/4 times 8 over 1. Notice I did cross cancel again. And then I did write it as negative 13x over 2 minus 26. Perfect. Let's take a look at our next two-word problem. Read and answer the question carefully. So Ray's parents agree to give him X minutes of screen time for every math test. He earns a 90 or higher. Last month, Ray got I scores higher than 90, and this month, Ray got J scores higher than 90. Which expression represents the total number of minutes of screen time Ray gets? This might be a little confusing with all the variables, so let's think about it. Let's say Ray's parents give him 20 minutes of screen time for every math test, and so that X will be 20. And maybe you got 3 scores higher than 90 and then 5 scores higher than 90. How would you figure this out? Well, it's X groups of 3 plus X groups of J. These are the minutes of screen time you're getting for every score higher than a 90. So if you got 2 scores higher, you'd get 20 times 2, which is 40 minutes for that month. So looking here, this would say you'd get 20 plus 3 plus 5 minutes, which doesn't make any sense. This says you get 20 groups of the total tests that you got over 90. Hey, that looks pretty good. I like that one. And then the next one says you get double the amount of minutes they're going to give you for I plus J. That's not going to work. And this just says you get 20 minutes for last month's test, but you just get the number of minutes for the number of tests this month. That'd be weird. They're only giving you 1 minute screen time for every test over 90. You need to renegotiate. So it is B. And I put a little star next to 15 if you know what I'm talking about. Okay, why don't you read 16 and then we'll go over it together. Did you pause the video? Perfect. Let's see what you have. So this is B. It's 2 groups of G plus F. So we're doubling our commission. Commission is a percent that you make of your sales. On the first day, you make F dollars in commissions. On the second day, you get G dollars in commissions. So a commission is a percent of your sales. Usually jobs that have large ticket items, because they're not selling as many of them, they're not usually paid salary, they're paid more of a percent of their sales. So a lot of car salesmen, maybe they get a small salary at how much they get paid for showing up, but then maybe they get paid like 2% of their sales because like a car is pretty expensive. Same thing with real estate. So if you are someone who sells houses, especially around here, you know, multi-million-dollar houses, if you're even getting 1% of that sale, you could be just selling 1 or 2 houses a year, but you might be putting in a lot more time than just getting those sales. Perfect. So great job on 16. So we have our second to last page, and we are going to be getting into modeling. So we're going to model and simplify the following expressions, and we're going to be prepared to justify our answer. So taking a look, we are going to have 3x plus 5, take away an x, and I already have 3 of them, so I'm feeling pretty good about not rewriting the definition of subtraction, and then 3 groups of x plus 2. So let's get started. I have 3 x's, which are 3 rectangles. I've got 5 singles, 1, 2, 3, 4, 5. I'm taking away 1 positive x, and I'm going to have 3 groups, 1, 2, 3, of an x and 2 singles in each one. So from there, what I total have is how many rectangles. I have 5 rectangles. And how many singles? You have 11 singles. Yay! Let's look at 18. So 18, we're starting with 3 x's. I'm adding 5 singles. I'm taking away an x, and I have enough, so I don't need to worry about that. And then I'm taking away 3 groups of x plus 2. So I need to be careful here. I'm going to need my 0 pairs. So we're going to start with 3 x's and 5 singles. I'm going to take away 1 positive x, and then I'm going to take away 3 groups of x plus 2, so I'm going to need 3 groups, 1, 2, 3. I'm going to need an x plus 2 and their 0 pair in each group. Almost forgot to fill those in. I hope you were yelling at the screen. Video bar, don't forget to fill those in. You're so kind. And then again, I am taking away a positive x and a positive 2 as a group. Whoosh, a whole group. Whoosh, Whoosh. So from there, now I can think about that there's a 0 pair and there's a 0 pair, so I'm left with a negative x. And I have 1, 2, 3, 4, 5, 6 negatives, and I have 1, 2, 3, 4, 5 positives, so I'm also left with negative 1, so negative x minus 1. If you wanted to write it as negative x plus negative 1, totally fine. Just realize that this is a little bit more simplified. Okay, I'm going to do 19 with you, and then you're going to do 20 on your own. So taking a look at 19, it's 2 groups of x minus 1 plus 4 groups minus 4x and then minus 6 positives. Ooh, I'm not going to have any 6 positives to take away, and I'm going to have 2 other x's. So I'm going to rewrite this with the definition of subtraction because it's getting a little crazy. So 2 groups of x plus negative 1, change that into brackets, plus 4x plus negative 6 plus 2x. This is going to be a whole lot more efficient to model now. 2 groups of x plus negative 1, so I have 2 groups. I'm going to have an x and a negative 1 in each one. I'm going to add in 4 positive x's. I'm going to add in 6 negatives. Sometimes I find when I'm putting in 6, like 2 groups of 3 is a little bit more clear. I'm going to add in 2 more positives. So I'll just add those on here. Okay, what do you end up with? Well, luckily it's all positive x's, so just add them all up and you have 8x total. And then how many negatives do you have? You have 8 negatives. You can write that as minus 8. Or if you'd like to write it as 8x plus negative 8, totally fine. Let's look at number 20. I want you to do 20 on your own. So pause the video and we will take a look at it in just a second. Okay, how did we do? Well, I decided to rewrite it with the definition of subtraction. So take away 2 groups of x plus negative 1. Otherwise, if you're taking away 2 groups of x and a minus 1, you're going to have like double 0 pairs there, which is so weird. So we're going to need to rewrite it. And since you're already rewriting with the definition of subtraction for these groups, I just rewrote it with the plus negative 6. So 2 groups of x and a negative 1 with their opposites to make those 0 pairs. I'm taking away the positive x and the negative 1 as a group, and I'm adding in 4 x's, 4 rectangles, 6 negatives, and then 2 more positives. So in the end, I have these 2 0 pairs that cancel out, so I'm going to have 4 x's, and I'm going to have these 2 positives that cancel out with 2 negatives, so I'll have minus 4. So the big question, what was our strategy when you simplified 17 through 20? Something that's really important is we needed to look at the expression to see if the definition of subtraction is going to make modeling more efficient. And then we created the groups first and then combined or added the separate terms. And then I wrote my expression completely simplified. So that was my strategy. Maybe yours is a little bit different, but we do want to look and see if that definition of subtraction is going to make this easier. So now we're going to simplify each expression without using models. This is going to be pretty cool. Where applicable, you do need to show your step that clears the parentheses and then simplify, and be sure to combine all like terms. So we might want to show some work for sorting our like terms as we're going. So let's take a look at this first one. 5 plus 2 groups of x minus 3. I'm distributing that 2, so I'm going to lasso it up. So it's 5 plus 2 groups of x plus 2 groups of negative 3. 5 plus 2x minus 6. If you like to write it as plus negative 6, be my guest. Very important though that in between the 2 factors, when I'm distributing, I'm always writing it as adding so I don't lose my negatives with my numbers. Now, combining like terms, I have a 1, 2x, and then I have a 5 and a negative 6, which gets me negative 1. Beautiful. Notice when I'm sorting my like terms, I'm drawing this line long enough so my brain sees that negative with the 6. I don't want to lose it. Okay, next one, I'm distributing that negative 2, circle it and lasso it up. I'm showing our step that clears the parentheses, then simplify. 7x plus negative 2 times 3x plus that negative 2 times 1. 7x plus, this gets you negative 6x plus -2. Sort out your like terms. I have a 7x and a -6x, which is going to get you a +1x, and then I just have that -2 at the end. If you want to write it as 1x, I mean, you can, but you don't need that 1 there. It's not completely simplified if you leave that there, because you can always multiply by 1. 1 times x is still going to get you x. Okay, you're going to finish that last page. Remember, you're showing your work, you're showing that distribution step, clearing those parentheses, you're showing combining your like terms, and then we are going to go over our answers together. So thanks for pausing the video. Let's see how you did. 24, 2x minus 13, 25, -3x minus 5. Again, don't forget you're circling the number you're distributing, showing that step. Number 6, -10x plus 9. Number 27, 26, I should say. 27, -9x plus 5. 28, -9x plus 7. And 29, -x plus 8. So this is the least amount of work you could show on these problems to be able to get full credit. So I did want to see that. Great job, mini mathematicians.